go over too much. So Cobra is really what I wanted to kind of focus on as our key application area. As I said, this one we started 2006 or so. We began working with a company called Mars, the one that does candy, Snickers and M&Ms and Milky Way are a few of its products. And they came to us with this problem. They used to be able to use clipping services to kind of track what was going on with their brands as far as news and issues that might cause people to view their brands in a negative light. But they were finding more and more that most of the stuff that was interesting out there was happening on the web. And that was a difficulty for them to track that. They had tried using various keyword services that would give them all the data that mentioned Milky Way and Snickers, but you can imagine how messy that was. Imagine all the stuff that mentioned Snickers every day on the web, and you could imagine what kind of junk they were trying to search through to find anything useful. So what they asked us to do is use our text mining technology, our exploratory text mining, to see if we could come up with ways to really boil that ocean down into something that was comprehensible by an analyst to make sense of. And so we built the Cobra system to do that, and we fielded it. And like a couple of months later, they came back to us and said, you know, this system's already paid for itself for the one thing we found. There was this new ingredient they introduced into one of their chocolate products called Renette or Renee, and it was something that came out of cow stomachs. And they suddenly noticed this spike in the vegetarian community where they were all upset about something. And they looked in Cobra and found that what was going on was a discussion was taking place about the fact that this candy was no longer vegetarian. We're going to have to stop. We're going to cause a big boycott against all your products. We're going to really do something that's going to, you know, make a big negative publicity about this particular candy. And so they found the key influencers, people who were really the leaders in this area, had discussions with them and decided as a company they were going to take that ingredient out of the chocolate. And they did that, made a big publicity thing about it, and really actually got positive publicity about something that could have been very negative for them. So they told us that all the money they'd spent with us to develop this product was paid for with that one issue. So how does Cobra work? It actually came out of a very simple idea, which is the power of independent rules. So think about it this way. There's a mathematics behind this, but actually mathematics is not very intuitive and actually doesn't really tell you very much. But if you think about it as bubbles, it makes perfect sense. If each of these bubbles represents a particular query that you're doing, and this is the actual data you want, depending on how different the queries are, if each of these queries represents a part of that data, it's an approximation of it, any one of these queries is going to have potentially very high recall, very low precision. The reason is it's kind of drawing a big bubble around an area and getting most of it, but you know it's missing. If you're any one place in it may be off the mark. So you're missing as far as precision, but overall your recall is good. What's interesting is and that's kind of the problem with individual queries about brands in the Mars case. Any one of them will get lots of relevant data, but if you start reading through it, it's mostly garbage. So the trick is to have a set of other queries that you can add to that, so that when you combine the two together, even though the two of them have very low precision, two of them together have much, much higher precision. But that only works if these two bubbles are not on top of each other, if they're as disjoint as possible. And that's the independence idea. So basically, that's what Cobra does. It develops a set of independent business queries where you have one set of queries that are talking about one thing, another set of queries that are talking about something totally unrelated. Put the two together and you suddenly have queries that are right on target. So the overall architecture of Cobra is pretty simple. It's kind of complicated, but really it's crawlers over here that are gathering all the different kinds of data from all the sources. Most of these are focused on social media. You can also use internal sources, like you have an 800 number that people call into Mars and they complain about a product. We can add that data there too. That all gets converted to XML, and then it's all loaded into a data warehouse where a set of extractions and transformations are done that are also saved in the data warehouse. Then there's a web-based GUI that actually does all the analytics and takes the stuff that's in the warehouse and displays it in graphs and charts and reports that are hopefully intuitive. So this is a back-end process where one analyst, kind of the expert, will kind of set up these queries that will go against the data sources to collect the data. In addition, they can set up a set of models. Oops. Use list instead. And those models can be built overnight and indexed. So you not only have the database, but you also have an index that you can use to do the queries. The models are set up ahead of time as well, and they really define what the brands are for the company and any other issues that they're interested in. So you can have like key players, might be the corporate officers. You might have competitors stuff. So you might have the competitor companies and their brands. All that's usually very helpful. Then there's a set of orthogonal things. These are orthogonal ones? No. Orthogonal things, which are kind of the independent models. Things like, in the case of bars, you're looking at like child advertising, legal issues, diabetes, poison, obesity, salmonella, all the things that they know these issues come up, that's a key problem for them. And then you use a generate utility to overnight do the analytics on the data, build the model, so in the next morning when they come in, all those things are ready to go in front of you. The kinds of analysis we do, you start with a dashboard. Look at the data as a whole, try to understand what are the major components, how often these components are occurring. And again, you've got taxonomies here. So this taxonomy is about source, message boards, blogs, Twitter. This taxonomy is about the brands. And this taxonomy is about the hot words, the hot issues. And so that's a way of sort of understanding what's happening. And then when that stuff is happening is the trend charts down below. And you can zoom in on those and kind of see when there's something interesting, a spike. You can zoom in on that, see the actual text with keywords highlighted, and a link that takes you back into the discussion if you want to see the whole thing in context. So there's a set of taxonomies we develop using text clustering as well as the different taxonomies that the user gives us. So you can break up the data in many different ways, and the co-occurrence table is available to let you see when there are connections between those different categories. This can often help you with the idea of discovery, where you may not know all the different hot words that are of interest to you or that people are talking about on the web. You may not know the vocabulary that people use on the web. So these kinds of analytics can help you discover where there's correlations, say, between your brand and other people's brands that are different. So relationships tables really take you to, here's a taxonomy on this side, and then on this side you'll see all the different things that are related to it. Here you can see sentiment, for instance. We have positive sentiment around customer service for this particular product. Co-occurrence tables really help us to see where there's significant areas. In this case, we're looking at the text clustering versus a set of user-defined categories. So where there might be interesting areas they didn't know about for any of these different acquisition things, we see different clusters that can be defined with it. Sentiment analysis. So the way we do sentiment, it's a very statistical process. What we do is we have a dictionary of all the positive words and all the negative words in the English language. And this is fairly common. You can find these dictionaries pretty easily nowadays. And then what we do is we go into WordNet and find the definition of each of these words. And given the number of positive and negative words in the definition, we come up with a relative score or how positive or how negative that word is. Then using statistics, we take each of the snippets around the product or the brand and look for the content of that snippet in terms of how many positive, how many negative words it has, and how what score each of those words has. So a very positive word, less positive words. Add up that score, divide by the sort of length of the snippet to normalize, and that kind of gives you the overall positiveness or negativeness of the snippet. Then you basically look at all the snippets as a continuum and divide it into quintiles. The most positive is labeled positive, the most negative is labeled negative. The 60% in between is labeled neutral. We do that because every domain is different, and you shouldn't assume that the same kind of relative arbitrary score for positive or negative will work in every domain. What you want is kind of a distinction made between the most positive stuff and the most negative stuff in any given area. And so this will help you to find that sort of disjunction between the most positive and the most negative concepts.
How do you deal with negation?
Yeah, that's the one NLP thing we do, which is basically we look for the negative words like not or nor or no, and we look for things that happen right after that, and we discount it if it's got a negative in front of it. For the most part, we don't do things like sarcasm and sort of things that you would only know by the context, and it works as long as you have enough data, as long as you have sufficient examples in a given set. It will find the interesting correlations. It doesn't work if you're saying any one particular snippet you're looking at, the ranking it comes up with might not agree with the ranking you would give that particular snippet. But to be honest, I've never seen a snippet calculator that can really do that any better as well as a human.